welcome back. So in this video, I'm going to go through some examples of computing the cross product. I'm going to show you how to do this with determinants, and then I'm also going to show you a shortcut method to make it a little faster. It's just a faster way to compute determinants. So for our first example, let's find u cross v. If we have the vector u, which is 2, -4, 1, and the vector v, which is 10, 0, 3. So I've been given my two vectors, and now I just need to compute the cross product. So I'm going to set up the determinant in order to find this. So I say that u cross v is equal to the determinant, where the first row is ijk, the second row is u, 2, -4, 1, and the third row is v, 10, 0, 3. Now to compute the determinant, I first use I, and then I do the determinant of the lower bottom right half. So I do -4 times 3 minus 1 times 0. Next, I subtract the j hat times the determinant of sort of the outsides. So I do 2 times 3 minus 1 times 10. Then I add this to k times the determinant of the bottom left, 2 times 0 minus -4 times 10. So I've now done the cross product. I just need to simplify this to get a final solution. So for the I component, I have -12 minus 0. Then for j, I have 6 minus 10. And for k, I have 0 plus a 40. So simplifying, I have I times -12 minus j times -4 plus k times 40. So in ijk form, this looks like -12i plus 4j plus 40k. So this is my ijk form, but I could also write this in component or vector form. So I'm going to write it as -12, 4, 40. And there we go. That's my cross product. Just as a reminder, the cross product, this vector we found here, is orthogonal to u and v. So we found a vector that is orthogonal to both u and v using the cross product. So I personally think that it can be kind of challenging to do the determinant and to remember the formula. So there's this sort of shortcut method that I've seen people use quite a bit. It's how I learned it and how I saw it again when I went to graduate school. So this is just a kind of a neat way to do the determinant in 3 dimensions. So let me show it to you. So we do u cross v, and we do the same determinant from before, but then I'm going to set up this kind of interesting layout and do some diagonal multiplication. Let me show you. So we're going to write ijk, and then we're going to repeat ij. So we're going to repeat those first two columns. Then I write 2, -4, 1, and I repeat the first ones, 2, -4. Then I do 10, 0, 3, and I repeat 10 and 0. So I'm sort of taking the I and j columns and repeating them at the end. Now what I'm going to do is multiply down these diagonals going from left to right. So I do I times -4 times 3 plus j times 1 times 10 plus k times 2 times 0. All right, so that's what I'm going to do first. So I have I times -4 times 3 plus j times 1 times 10 plus k times 2 times 0. Then I go backward down the other diagonals. So I go j times 2 times 3, I times 1 times 0, and k times -4 times 10. So I get minus j times 2 times 3, minus I times 1 times 0, minus k times -4 times 10. So we add the sort of forward diagonals, and then we subtract the backward diagonals. I'm not going to go through why this works. Hopefully you can just kind of do it with me and trust me. For now, I'm just going to give this to you as the shortcut method, and you'll see here that we're going to get the same answer as we did using the first method we had. So I can combine things together. I have -12i plus 10j plus 0k. Then I have minus 6j minus 0i plus 40k. Combining like terms, I have -12i, I have 4j, and I have 40k. And writing this in component form, I have -12, 40, which is what I got using the original method. So this other way of solving a cross product is just like another way to do it. I personally like it. I think it's a little neater than trying to keep track of things depending on where you are in the determinant. So this is the shortcut method, and I tend to use this when I'm doing cross products. So to wrap up, I just want to do one more example of sorts, and this is going to give us some more information about cross products. So the question I have for you is, we did U cross V. Is this the same as V cross U? So U cross V is -12, 4, 40. We found that already. But let's find V cross U and see if they're the same. So I'm going to rewrite my U and my V vectors here. And now we'll do V cross U. So to do V cross U, I'm going to set up my determinant. So now it's just the middle row is V and the bottom row is U. And I'm going to use my shortcut method where I keep the original 3 columns, the I, J, and K, the same. And then I just repeat the I and the J column at the end. And I'm going to add the forward diagonals and then subtract the backward diagonals. So I do I times 0 times 1 plus J times 3 times 2 plus K times 10 times -4. And I'll subtract the backward diagonals. J times 10 times 1 minus I times 3 times -4 minus K times 0 times 2. So I can simplify now. I have 0i plus 6j minus 40k, and then I'll have minus 10j. That's going to become a plus 12i, and then a minus 0k. So combining like terms, I have 12i, I have minus 4j, and then minus 40k. So that's 12, -4, -40. And so these are my solutions to my cross product, both in IJK notation and in vector notation, or component notation. So we can compare now. So U cross V was -12, 4, 40, but V cross U was 12, -4, -40. So it was just different by a negative sign. And basically this means it just points in the opposite direction. And so what we can say is that A cross B in general is equal to the negative of B cross A. And this is just a fact that we now know about cross products from going through this exercise. All right, that is it for examples with the cross product. Hopefully that shortcut method comes in handy as you're going through it, instead of having to memorize the determinant method. Thanks so much for watching, and I will talk to you in the next one.